Watching this, you're watching the geometry review for grade 8. So this will cover materials from grade 7 regarding geometry. This lesson is important because we will go over triangles and other types of geometry in grade 8, and a lot of this information will require you to remember things from the previous years. It is important because there's a lot of tricks that can happen in geometry where it seems that you have some information, but you actually don't. And I'll go into more detail as we go along. So, what is geometry? Geometry is the understanding of the math that is in shapes. So, shapes are defined by certain things, right? What defines a square? A square is a shape where all sides are equal and has four corners. A rectangle has two equal sides and another two sets of equal sides with four corners. And triangles have three corners. So geometry is basically the study and the math of what is required to create these shapes, for these shapes to follow within their definitions. So there's a couple terms you have gone over from grade 6 and grade 7, and that is perimeter and area. Well, you should know that perimeter is the distance around the edge of a shape. So if I were to draw let's pick a square, we'll draw a little square here, then perimeter is basically, all it is, oh, what is the length of this side, and this side, and this side, and this side? And then you add up all that area. So if I were to give this length a specific size, so let's just say 4, because I like that number, 4. Okay, well, we know for a square to be an actual proper square, all sides need to be equal. So 4, 4, and 4, we have our 4 corners, so it is indeed a square. Okay, well, a perimeter is, how long is this side? 4. 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 Well, the side length is equal to 4, but the perimeter is all the side lengths added up. So 4 plus 4 plus 4 plus 4, so it's 16, right? So a common mistake students make is they confuse perimeter with side length, especially with squares because the number repeats itself. So be careful with that. Perimeter is the total sum, or adding up all the side lengths. Area is how much space the shape takes up. So again, I'm going to take my square, make a different square here. All area is, let's do that. Area is everything inside the square, right? So perimeter is the lines along the outside, right? You add those up, the side lengths, you get your perimeter. But area is the length of each side. So again, we'll say this guy's 4 by 4, right? My 4 by 4. Now, with squares and rectangles and those four-sided shapes, you can get the area of any shape like that by multiplying, not adding, multiplying one side by the other side, right? So 4 times 4 is 16, right? So how do we calculate perimeter? Again, we've gone over this. With squares and rectangles, it's, well, the A, so the length of A times 4, because all the sides are the same. So if A was, for example, again, 4, well, then that'd be A times 4, right? Because there's 4 sides. So that'd be 4, and that'd be 4, and that'd be 4. Okay, well, let's say we have a rectangle. Well, now all the sides aren't equal, but this side and this side are equal. So we have 2 of those. And we have 2 of these guys, here and here. So what we can do is we can take the side of A and multiply that by 2, because we have 2 of these sides. So let's say this guy is 6. And let's say this side is 2. Okay? So 2 A's here and here. So that's 12. So we have 12 plus 2 B's, right? B is 2, so we have 4. And for some reason, I am constantly sticking to the 16. But yes, our perimeter here would be 16. The triangle, really easy. You just add up each side. So you need to know the length of each side. There are different types of triangles I will review. But if you know all three sides of the triangle. If this was 2 and 3 and 4, for whatever reason, you could just add up 4 plus 3, which is 7 plus 2, which is 9. Done. Now, depending on the side of the triangle, if it's an equilateral triangle, equal meaning same, all the sides are the same length. If it's isosceles, two sides are the same. If it's scalene, all the sides are different. So these three shapes tend to be particularly easy for perimeter. It's not particularly difficult. It's just go through the steps. The part that usually catches students are circles. Circle geometry tends to catch most students, and that's because there is an equation you need to know. You just need to know it. There's no cheat really for it, or at least one that I know of, that you can use to calculate the perimeter of a circle. So you need to know it's 2 pi r. Well, what does that mean? Well, let's start with r. Okay, so here you can see my circle. I have a dot right in the dead center of my circle, and I have a line leading from the center to any edge. So this line could have gone here, or there, or there. Any line that goes from the center to the edge of a circle is called our radius. And if it were to go all the way through, so if I were to draw another line all the way across, that would be our diameter. But I like to deal with radius only because it's the one unit with regard to circles that shows up the most. So any line from the center to the edge of a circle is our radius. Okay, so 2, and it's next to pi, so that's 2 times pi times r. 2 times pi times r. So we have a radius, the length of this. So let's say this is, I don't know, 2. So our radius is 2. So pi, you can use, and pi is an interesting number, and you'll go into it more in high school, but we'll use the digits 3.14. Even though pi is forever, we'll use the digits 3.14. So the equation for circles is 2 times pi, so 3.14. And you can see I'm using a dot for multiplication. 2 times 3.14 times r, and in this case, our r is 2. Right? So you have 2 times 3.14 times 2. And that's it. You just multiply all the numbers together. So if you know what your r is, you just need to know that pi is 3.14, and you multiply everything by 2. That's it. So know this equation. Know it by heart, because it shows up in grade 8. It'll show up in grade 9, all the way through math in high school. And if you decide to take math in university, I guarantee you it'll show up there too. So know 2 pi r is the perimeter, for the perimeter of a circle. Another mistake students commonly make, they mix up their equation for perimeter and area. So area of circles, or area of these geometric shapes, including circles, follows this. So squares are the side times the side. So again, if we had the square of 4 and 4, well, this side and this side are equal, so it's a and a. So 4 times 4, which is 16. So our area is 16. Rectangles is this side times this side. So if this side was 4 and this side was 2, that's a weird looking 2, that's 4 times 2, making that 8. Right? That's it. You multiply one side by the other side. Now, you don't multiply it by the opposite side. Don't do that. You multiply it by the side it's next to, like this, from that corner to the next corner. Do not multiply opposites because you'll get the wrong answer. So these two, again, super duper easy to do for area. Triangles. Okay, and I'll explain why this works in more detail later. But triangles is the side of the length of the bottom side. We call this the base. The base of the triangle, the bottom part of the triangle, multiplied by the height, or h, multiplied by the height, divided by 2. So let's say we had 4 again as our base, okay? And let's say the height is 2. Okay, so if our base is 4, so that's 4, times our height, which is 2, which gives us 8. Okay, but remember, it's also divided by 2. So then I divide that answer by 2, which gives me an area of 4. So the area of this triangle, if these are the units we're using, is 4. If this was 3, it'd be 4 times 3 divided by 2, which would be 12, and then that would be 6. So that's tricky, and there are a couple of tricks that will show up on tests, especially later in years, where you'll end up with a line down the middle, but it's a little bit tilted, and that doesn't give you the height, and you'll go over that later. Another hard one is our circle. Again, it's pi r squared, not 2 pi r. 2 pi r is perimeter. Pi r squared is area. So if you recall from grade 7, if you see a little digit like that, that's your exponent, right? So r squared, so any number squared is multiplied by itself. So if I have 2, I put a little 2 there, just like that r squared there, that's the same as saying 2 times 2. 2 times 2. Let's say I had 3 squared. 3, and you have a little tiny 2 there. That's the same as saying 3 times 3. It's multiplied by itself. That's it. That's all it is. So knowing that, and we'll go over this again after we do probability. Knowing that, let's say our r is 4 again. Cool. Let's use 4. Okay. So the area of this circle is equal to pi r squared. We know pi always equals, and we'll use the shortest form of pi, 3.14. This is what you're going to run into most of the time, 3.14. We know in this case r equals 4, and the equation is pi r squared, right? So this is pi times 4 squared, right? Well, we know 4 squared. 4 squared is 4 times 4, right? So 4 times 4 is 16. So it's 16 times pi, and that's it. And you can punch that into your calculator. Students make big errors because they will confuse the area of a circle with the perimeter of a circle, because they're very similar, right? This 2 is here, 2 pi r for perimeter, and then the 2 shrinks and then jumps over to the r to make it pi r squared. So a lot of times students make that error. So please, please, please know 2 pi r as your perimeter and pi r squared as your area. So find the perimeter of these shapes, right? Now, this is an example of a type of question I may ask you on a test. And I'll give you a hint on this one. This triangle has some useless information in it. We're trying to find the perimeter of a triangle. What don't we need? And what is required for a perimeter calculation of a triangle? Here we have a circle. We have this line from the center to the edge. You should know what that's called. It's the radius. We have a radius of this number. What can I do to find the perimeter? Well, another word for perimeter of a circle is circumference, or to go around. The circumference of a circle. And then you're going to be learning about angles. And in high school, angles and trigonometry regarding triangles is huge, and it will show up big time in grade 11. So know your angles, at least know what types of angles you have. So all an angle is the amount of turn between two lines. The amount of turn. So from this line turns 116 degrees there. So the angle will be 116 degrees. This line, right? This line here. The other line turns 94 degrees that way. That's all it is. That's what angles are. The amount of turn between two lines. There are types of angles. You need to know 3 types of angles. Acute, obtuse, and right. Acute is like this, obtuse is like this, and right is like this. And hopefully you do remember this, but I'll quickly review them. Acute angles, well, the amount of turn between the two lines is less than 90 degrees. So as long as it doesn't go past that 90-degree turn, for example, 55 is less than 90, you have an acute angle. You have an acute angle. An obtuse angle is an angle bigger than 90 degrees. So if we have this line and the amount of turn, for example, in this one is 120, then you have an obtuse angle because it goes past 90 degrees. And the last but not least, the right angle. It's an angle of 90 degrees. So it's not acute, less than 90. It's not obtuse, more than 90. It's just right. Squares and rectangles always have 90 degrees. They make that L shape, right? Right? They're all 90-degree angles. 90 degrees, so on and so forth. So they all have 90-degree angles. You will not see a square with obtuse angles because you can't. A straight line, it has a 180-degree angle. So if you were to draw one line going this way and one line going this way, the amount of turn going all the way around like that is 180. And circles have 360 degrees in total, right? Because what you've done is you've taken a line, you've taken another line and gone all the way around, that's 180, then you go another 180 to go back around to make a circle. That's an ugly circle, but yeah. So basically, a straight line has an angle of 180 degrees, and a full circle has an angle of 360 degrees. Always. You will not have a circle with 250 degrees. It's always 360. Triangles always have their angles add up to 180. So it's not saying that triangles are straight lines. It's saying that if you take the angle here, we call this angle A, you take this angle here, you take this angle here, and you add them all up, they will always add up to 180. If you have three angles in a triangle and they do not add up to 180, you did something wrong. Because clearly you have a triangle, but those angles aren't adding up to that rule. So that's a way you can check when you're making triangles. Did I have all my angles add up to 180? So we can do some practice here. Try and figure out x using what you know of these two angles. Now we just covered the rule of triangles, so you can take a peek back, but this one shouldn't be too hard. This one's a little tricky. As you can see, there are more than one triangle, so you can try and fill in the blanks as you go along. It's a tricky question. We'll solve this one in class. If you have trouble with this one, if you are watching this at home, please just come to me in class and I'll show you how to solve this one. It's easier than it looks, but it can be tricky if you don't remember the rules of 180 for every triangle. So you just got to find each triangle and know what the angles add up to, and you can also use that 180 rule, the 180 rule, right? A line has an angle of 180 to solve this equation. So right now, I'll give you a hint, 80, so from this line to here is 80. From here to here, we don't know, but from here to here is 65. So from here to here, that's a straight line from this point, right? So that should be what? And if you know that, then you know that this should also equal something. So something is missing here to fill in that spot. And that's how you find A. And once you find A, well, you have these two angles. You can find B, you finish that triangle, and then you can do a similar thing here for C, and then you can find D, and so on. So it's easier than it looks. You just take it one triangle at a time. Try and do these ones as well. Angles get tricky because you have to use a bit of spatial awareness, and it can be challenging to sort of remember the rules of angles and what kinds of angles you have and how they work and what shapes need to have certain angles. So practice these, know them, and you will be doing just fine for these types of questions when they show up. Thank you for listening, and I will see you next lesson.